Okay, this is the first lesson for chapter 5, which is on factoring. And we're going to start off slow and we're going to talk about factoring integers, and that includes finding the greatest common factor of several numbers. Okay, so this is basically a review. So when you write 56 is equal to 8 times 7, or 56 is equal to 4 times 14, you have factored 56. In the first case, the factors are 8 and 7, because factors are any numbers that you're multiplying to get another number. In the second case, the factors are 4 and 14. You could also write 56 is equal to 1/2 times 112 and call 1/2 and 112 factors of 56. Usually, however, you are interested only in factors that are integers, and usually it's also positive integers. To factor a number over a given set, you write it as a product of numbers in that set called the factor set. Integers are factored over the set of integers unless otherwise specified. The factors are then integral factors. So basically what this means is if I have an integer and I'm going to factor it, I'm really looking for integer factors. So when we had 56, which is an integer, and we said that 1/2 times 112 are both factors, 1/2 is not an integer. So we would not normally factor 56 in this way. Okay, we would usually factor it 8 times 7 because those are both integers, and 4 times 14 because those are both integers. So the factor in the factor set, if the factor is an integer, then our factor set is generally integers. And these factors are called integral factors. And if you look, you see it looks like integer. Integral factors just mean that the factors are integers. Okay, so let's start by giving all the positive factors of 56. Now, the easiest way to do this is to go through the divisibility rules, starting with the smallest number and writing things as pairs. So obviously, 1 times 56, so those are both integers and they're both factors. 2, and that would be 2 times 28 will give me 56. It's not divisible by 3 because 5 plus 6 is 11, which is not divisible by 3. Is it divisible by 4? Yes, it is. 4 times 14. Okay. The 1, the 2, and the 4, those are factors that are usually easy to find. We forget about 56 normally. 28 and 14 are a little bit harder to think about. So it's easier when you do it as pairs because then you're less likely to forget. Okay, it's not divisible by 6. It is divisible by 8 and 7, which we already said. And then the next one would be 14, so we've already listed it. So these are the integer factors or the integral factors of 56. 1, 2, 4, 8, 7, 14, 28, and 56. Okay, so that's one way to find all the integer factors. So a prime number, also referred to as a prime, is an integer greater than 1 that has no positive factor other than itself and 1. So the first 10 prime numbers are 2. 2 is also the only even prime number. Then we have 3, 5, 7, and I think that's it. Yeah, because we're only going to, we're looking for the first 10. Okay, so 2, 3, 5, 7, 11, 13, 17. That's 1, 2, 3, 4, 5, 6, 7. 3 more. 20. Oops, forgot 19, 23, and I believe 29 is the next one. Okay, so to find the prime factorization of a positive integer, you express it as a product of primes. So one method is to use a factor tree, and each integer has only one unique prime factorization. So we're going to look for the prime factorization of 504. I'm going to do a factor tree, and then I'm also going to show you how to do it using what's called a ladder, which some people like and most people hate. So factor trees, what I need to do is come up with a factor pair, okay, like what we did up here, that I can multiply those two to get 504. And you're probably going to need to use a calculator for this. All right, since this is an even number, I know that it's divisible by 2. And 504 divided by 2 is 252. Because 2 is prime, I'm going to circle it because I know I'm done with it. 252 is also divisible by 2. And that gives me 126. Okay, circle that too. 126 is also divisible by 2. And that's 2 times 63. And then 63 is 7 times 9, and 9 is 3 times 3. So the way I write the prime factorization is I take my smallest prime number, which is 2, and I have 1, 2, 3 of them. And then my next prime number, which is 3, and I have 2 of those, and then I have a 7. So that is the prime factorization of 504. If you wanted to do what's called a ladder, you go in order. So you keep going with the 2. So it would look like this: 2 times 252, and then 252 is 2 times 126. 126 is 2 times 63, and 63 is 7 times 9, and 9 is 3 times 3. Okay, so it's just another way of doing it, except you're dividing by a prime each time. So this one I might have said, well, it's divisible by 9. So if I divided it by 9 first, I would have 9 times 56, neither which of those are prime. Okay, with the ladder, you have to divide it by a prime every single time. So again, we get the same answer though: 2 to the third times 3 squared times 7. Okay, so that's how we write the prime factorization of 504. And really, it's the same as 2 times 2 times 2 times 3 times 3 times 7. Okie dokie. All right, so a factor, make sure everything is visible. A factor of 2 or more integers is called a common factor of the integers. The greatest common factor of 2 or more integers is the greatest integer that is a factor of all the given factors. So greatest common factor, it is what it's called. It's the biggest factor that the 2 or more numbers have in common. Okay, and we can find those using factor trees. So if I look at these two numbers, finding the greatest common factor just by listing factors is going to take me forever, and I'm probably going to skip some. So I'm going to go ahead and do the find the prime factorization of each one, and I'm going to do it using ladders just because it takes up less room. So because it's even, I start by dividing it by 2, and that gives me 441. Okay, well, 441, if I add these together, 4 plus 4 is 8, plus 1 is 9, which tells me that it's divisible by 9, but also divisible by 3. So I'm going to divide it by 3 because 3 is a prime number, and I can only put primes over here. So 147, if I add that, 1 plus 4 is 5, plus 7 is 12. So this one's also divisible by 3. That gives me 49, which is divisible by 7 and 7. So I'm going to go ahead and list them out here. And I'm going to list them in order. So I've got 2, 3, and I'm going to leave some spaces, and 7. All right, now we have 945. So I'm going to do the prime factorization. It's not divisible by 2. It is divisible by 3. Gives me 315. And that would be 8, 9. That's also divisible by 3. This gives me 105. That is also divisible by 3. Gives me 35, which is 5 times 7. So I'm going to write these out. 945. And I don't have any 2's, but I have 3 3's. 1, 2, 3. I'm going to put them kind of in the same area as these other 3's. I have a 5 and I have a 7. So what I'm going to do there is I'm going to then figure out what factors they have in common. They each have 2 3's in common. They have a 7 in common. So 3 times 3 times 7. I'm going to multiply those. 3 times 3 is 9. 9 times 7 is 63. So their greatest common factor is 63. If I divide them both by 63, 882 divided by 63 gives me 14, and 945 divided by 63 gives me 15. And as you can see, 14 and 15 have no common factor. So the greatest common factor they have is 63. All right, so let's find the prime factorization of these two numbers, okay? We can do it by ladders. We can do it by factor trees, whatever you choose. This one I'm going to go ahead and do I'm just going to do a factor tree. I know 5 times 9, and then 9 is 3 times 3. Make sure that you're circling your primes, and that if you have a number that's not a prime number, that you keep going. So this is 3 squared times 5. If I do this one, I know it's divisible by 2, and that gives me 42. And I know that's divisible by 2, and that gives me 21. And that's 3 times 7, which are both primes. So 2 squared times 3 times 7. So those are the prime factorizations for those. Now it says find the greatest common factor of each pair. So again, these numbers are small, so I could probably figure it out pretty quickly. But I'm going to go ahead and list their prime factorization. So this would be 2 times 2 times 3. 2 times 2 is 4, times 3 is 12. And this one's going to be 2 times 3 times 3. So they have a 2 in common, and they have a 3 in common. So 2 times 3 is 6. So their greatest common factor is 6, which you probably could have figured out without doing all of this. I just want you to see how it works. This one looks a little bit harder. 23 is prime, so its factors are just 1 and 23, and we're not going to list 1 because it doesn't do anything for us. 46 is even, so it's divisible by 2, and 46 divided by 2 is 23. So their greatest common factor is 23. Now here's something you need to know. The greatest common factor cannot be any bigger than the smallest number. So if the smallest number is 23, the largest my greatest common factor can be is 23. So that's it for greatest common factor and prime factorization.